Action.
Alright, so for question 1, it's asking what proportions of crows in the sample have lead levels that are classified as the biologist as unhealthy. So for here, as if we look at the passage above, it says that the biologist classifies lead levels greater than 6 parts per million. So if we look at the table that's given, we notice that 4 of the 23 parts are higher than 6 parts per million. So we put 4 over 23, and that's how we got our proportion of lead levels that are classified as unhealthy. So next, it's going to ask us to construct a confidence interval relating the crows. So
And the first thing you have to do for the confidence interval is state your conditions. 3 conditions are random, independence, and normality. Random is given in the passage above. It says that it was a random sample. For independence, you state that 10 times the sample size is less than the population size, and the sample size is 23. And so you have to assume that there's more than 230 crows in the area for independence to be checked. In normality, since the sample size is less than 30, CLT is not met, but the distribution of the the lead levels in crows seems approximately normal, so you can continue on with the inference.
yep. So and just to clarify, the normality is n has to be greater than 30, but in this case it's not, so that's why CLT is not met. So next we're going to go into the math part. So our equation for all confidence intervals are stat plus or minus the critical value times the standard deviation of the stat. So in here we know our stat, which is the mean, is the mean sample was 4.9. So we have our stat here. We're going to do plus or minus. Our critical value right here is going to be the t-star distribution. So if you look on your formula sheet, you can easily calculate it by using the degrees of freedom and the confidence level that was given. So here, then we're going to do the standard deviation of stat, and this is sigma over the square root of n. In this case, our sigma was 1.12 over the square root of n, which is the square root of 23. Then when you do the algebra, our confidence interval comes out to be 4.416, comma 5.384. And next, we're going to go over to the conclusion.
The conclusion is I am 95% confident that the true mean of lead levels falls in between the interval 4.416 and 5.384.
Thank you.